So we've created a basic setup for a rig. We have our geometry. We have a manual rig. We also have a rig created with a skeleton node. I've got very basic orientations here and I haven't set them up properly, but none of these rigs are actually practical rigs in any case, so that is not important. I have created nulls for referencing the rig, but I do not currently have a reference to the weighted mesh. So I'm going to create a reference now, and I'll do this with a null. I'll connect this just before the bone deform node, after we have weighted the geometry. This will be connected to the first output of the joint capture biharmonic node. I'll call this node mesh out. I'll give this null a green color. Here I have a basic graph which I set up with script. We do not specifically need this anymore, as now we'll look at setting up the geometry. Apex has a specific geometry format, and this relates to pack geometry. And this format allows us to organize scenes as well as characters. It does also give us functionality for extending characters, so we can add things like extra constraints to our characters and to our scenes. To look at this format, I'm going to open a pane next to my parameters. This will be under the animation submenu, and it is the rig tree pane. This is usually used for KineFX. This will give us a representation of the hierarchy of the skeleton and will allow us to look at the joints themselves. However, we now have the ability to have a type for this pane. For our skeleton, if we want to look at the hierarchy, this is joints, but we now also have the ability to look at packed folders. The packed folders will allow us to examine Apex geometry, as the Apex graph is not the only part of Apex geometry. So now we'll start assembling our character, and to do this we'll need a packed folder node. The creation for our character for a rig will start with this node, and this will usually be the first Apex node that we need to use within a network, and we will not be able to create a character without using this node. I'm going to set this with object merge nodes. We'll use these to reference our geometry. I could connect my networks directly, but this is a neater approach. All of our geometry will be connected to the second input, and currently we have two sets of geometry which we're going to reference, and these will be our mesh and our controls. Here I'm going to create two variants of this, one with my manual setup and one with the skeleton node setup. I'll then color these nodes. For my personal conventions, meshes are green and skeletons are purple. I can then rename my merge nodes. I'll then set references within my object merge nodes. For the mesh, I'll reference the mesh out null. For the skeleton, I'll reference my manual out null. For my second network, I'll have the mesh out referenced for the mesh again, but my skeleton will reference the skeleton out. These networks are essentially going to be identical, but creating them both is useful for displaying other aspects of the Apex setup, and is useful for showing how the packed geometry format works. The pack folder node is the node where we will assemble our geometry for the rig. The first input is for an Apex graph. So for example, we could start with an edit graph node being passed into this input. That is not something which will automatically work well, and there are better ways to approach this. This will also not be necessary in most cases, as we'll usually generate our graph in a different way when starting out the rig, but it is useful for more compound rigs, where you're either joining characters or performing constraints on objects. So the first input will take a graph, the second input will take any geometry which you're adding to the character. That will include Apex graphs. Here we have a standard multiple input list. The first input within this list is currently empty, and this represents the input for our edit graph. So if I was to delete this input, the second input will now automatically be connected to our mesh. This is of course not what I want. I'll reconnect my mesh to the second input, and I'll reorder the inputs as per normal. We should see here that we currently have two generated options for our inputs. By default, we'll change the name of the incoming geometry. It references the node, but I'm going to change this to base. You can use a character name here, or any other type of naming that you prefer, but the default name you should use is base. So if you do not have a specific name, you want to use base as the name. The reason you want to use this name is that all the default Apex nodes, and especially the auto-rigging nodes, use base as the default name for a rig, and will refer to geometry with base in the name by default. So until you're comfortable with how the naming works, the default naming is the best option. To show this, we can look at the auto-rigger node. So when we're working with the auto-rigger node, we'll be connecting this to our packed geometry through the first input. We can then enter this node, and we can take a basic look at how this works. The geometry will be read through the nodes which have a purple color, and will come in through this input here. Beneath this, we'll have a section which does error checking. This makes sure we have a valid input. We then have an attribute wrangle node which is creating a number of dictionaries, and these are adding information to our geometry as detail attributes. It will do this with information from the geometry itself, as well as information from the interface. The same will apply to the node after this. This node will generate some name attributes and some rig attributes based off the interface, and these attributes are used to generate our graph. We can generate a graph on our own, and we can use previously made graphs or characters with this node, but if we do not have a graph, this is where the network generates attributes in order to create the graph. This is fed into an invoke node, and this is where the processing will be done to create the graph. These attributes are stored in a params dictionary, and this node takes that dictionary as one of the inputs. This node will also output a dictionary, but that will only contain one value, and that attribute is a path, and that is the path to the graph this rig is creating. And by default, that graph will be called base.rig. We will examine .rig a little bit later. Needless to say, that is the name of the character that this graph is generating. We then have a file node here, and this is important in Apex Network. This node is used to find and generate the graph for the rig. So if we have a graph, this network should find it. If we do not have a graph, we should generate this graph. That's the main section for the geometry. We also have the pink section. The pink node will run over our graph and update it. This is the main functionality of this node, apart from if we use the second input, in which case this node will be bypassed and we'll use the second input instead. This part of the network will be run over the graph in the invoke node here, with this stash node checking our character details. The stash node contains an Apex graph, and once again the standard functionality for these nodes is to look for character components which have the name base. Once again, this can be changed. For example, if we go to the interface for this node, we'll see that there's a name for the rig, and that is currently base.rig. And this name over here is the name for our graph. We can work with more specific names later, but we'll work with this for now. So over here, all the components of our character are named base, and after our name we have a type. The type option implies the functionality of the geometry coming in through the input. We can create custom types, but for the most part we'll use the types defined by Houdini, as these will be used by the default nodes when we're creating our graph. Our first input is for the mesh. So if the name of this rig is base, the type of the mesh will be shape. Essentially, this will be base.shp. The next input is for our skeleton. Skeleton will also be abbreviated automatically, and this will be the equivalent of base.skele. There are a number of other default options that we can use. I'll add a null here, and this will allow me to look at these without resetting the options I've just set. The first option here is types from input. None of these have existing types, and this kind of option is generally one which I prefer not to use, as I prefer to be explicit on my types. But if you have a pre-existing type, this can make your life easier. After this, once again, we have our shape, which in terms of rigging would be our character mesh, or any geometry we're using as part of the rig. After this, we'll have our skeleton, and that will be followed by our rig. The rig represents our final graph which we are generating, or any final graph for a character which has been added to a scene, and this will depend on context of how you're setting up your characters and scenes. In either case, the rig is what will be displayed in our final viewer state. After the rig, we have the controls. This is supposed to be used for UI controls which we create, and these are supposed to be aimed at the UI for the rig, less than the direct controls of the rig itself. This is one of the areas which is not particularly well documented at the moment. It'll still be a while before we look at this. We can also add a pre-existing character. This should be a full graph with appropriate geometry for both the mesh and the skeleton. Essentially, the character is what we're generating from our packed folder node, and a graph is an individual graph by itself. You'll often need graphs for things like constraints, or graphs which interface with the rig but do not actually directly affect it. Essentially, this will allow a graph in our network which is not specifically part of the rig. There are, of course, certain default names here which you probably do not want to use. For example, scene.graph would probably be a bad idea. Essentially, this allows us to store extra functionality which is not part of the rig. So this will give us our basic character, and the character can either be animated by itself, or we can add it to a scene. For this, we have the Apex Scene Add Character node. This node can either take graphs in terms of the AutoRigger graphs, or it can take pre-made characters, and you'll usually use pre-made characters with this. And essentially what we're going to add to this will be the character, and this will be the same as when we add a character to the packed geometry node. After we've added characters to the scene, we can add these with the animation node. In general, we'd connect this to an exported character. We wouldn't connect it as part of the rig setup. So all of these options which we've looked at will be part of the geometry which comes out of this node, and this geometry can be viewed in our rig tree. We'll now see that we have a hierarchy within this rig tree. This rig tree would now constitute a character which contains a null.graph element, a base.shape element, and a base.skeleton element. This format is not limited to a single character, so I can update the second network. I'll give all the elements their name. In this case, once again, they'll be base, and these will be base.shape and base.skeleton. So here we have our shape and skeleton again, and this should now constitute a second character. And what we can do now that we've got two characters is we can get another pack folder node, and we can connect both of our existing characters to this pack folder node. And now we can look at some of the other options we have. Without any types added, these will show up as individual entities, but they don't carry any information. We could specify that one of these is a character. Our hierarchy should now change, and we should be able to control the visibility of this character now. There is, however, another option which we could use here. Instead of specifying this as a character, we could specify this as a folder. This is another way of storing the character. However, the access options here will be different, as we cannot access this with .char. And we could apply this to both of our characters. And here we're storing both of our characters as part of the geometry structure. Essentially, we have a basic scene here, with two characters being part of a folder, and each character being populated by our geometry, with the main geometry here being our skeleton and our mesh. Once again, we can specify our main graph. For example, I could specify the main graph here by connecting an edit graph node and giving this the type of rig. So for example, I could call this base.rig, but the most common use would probably be doing this with the AutoRigging nodes and have this node generate our base.rig element. We can look at the hierarchy for our AutoRigger node. Here our geometry has the base.rig component, in addition to the components that we added to our packed folder. So this creates our character geometry, and then essentially what we're going to do is create a number of scripts, usually using an Apex graph, to populate the logic of the .rig graph. So for example, I could change the functionality of this AutoRig node, and I'll set this to be an FK network. This AutoRigger node is now generating a network, and we can view this with our unpack folder node. This will be connected to the output of my AutoRigger node. This will give us all the nodes from the output. A number of the nodes here are not related to our final rig, but are related to the other geometry within our network. We can specify specific elements. We can do this through typing, or we can pick an element. For example, I can specify the rig here. Doing this will isolate our final network, and we will not have any extra nodes showing up here. So that's our basic geometry setup. Once again, we create our final character. And here I have my mesh and my skeleton attached to this character. Although we may have specific controls and specific graphs for functionality which is extra to the character itself, we could also attach other characters. The output of this node can then be dealt with by a custom rig setup, or an AutoRigger setup, or a combination of both. I will look at both of these, although I will spend more time on custom networks. Creating custom networks is not strictly necessary, and they are more difficult to create, but they do give you a better understanding of how the networks actually work. So this is the basic setup, and should give you a basic idea of how the packed character format works.